Hello everyone, welcome back. This is Engineer Hussein Mwasapi. So in this video, our objective is given a known vector or component and resultant vector. Can we find the unknown component? That's the objective. So given a known vector, could also be just referred to as a component, and the resultant vector, find the unknown component. It can also be vice versa, but provided that they have given you two things, it's okay to find the other missing thing, because having two things gives you enough information to find the missing object. So that's the case. So given a known component and the resultant vector, let's find the unknown component. So we have one known component, we need to find the other component that's not known. Okay, so before we begin, don't forget to hit that like button and subscribe. Okay, so we'll understand this with an example. Two forces act on the hook shown in the figure. Specify the magnitude of F2 and its coordinate direction angles so that the resultant force Fr acts along the positive y-axis and has a magnitude of 800 newtons. So I've been given some information about force 1, which is the first component, and we need now to find the details of F2, which is the second component. We have been told that the magnitude of the resultant is 800 newtons, and the resultant acts along the positive y-axis. So this means that the resultant is acting along the positive y-axis. Remember, this is the z, so the y is this side. So this is where Fr is acting, and Fr is 800 newtons. Now we know the value of Fr, and we know that Fr is only positioned in the J. F1 has positions that are dependent on the directional angles that are present. We have 45, 60, and 120 degrees. So let us now try to find this unknown component, which is F2, just using the resultant and one of the components given. So the first thing we'll do is to find or express F1 as a Cartesian vector, because we need to express most of these vectors as Cartesian in order for us to evaluate them. So every time you have these coordinate directions, always express the force or the vector having the coordinate direction in Cartesian form. So let's do that. So we need to understand that force 1, it will be equal to F1, the magnitude, cos alpha, that will be in the I, plus the magnitude of F1 cos beta, that will be in the J, plus the magnitude of F1 cos gamma, that will be in the what? K. This will be the Cartesian vector of F1. Now we need to understand that the magnitude from data. Okay, let's collect data so that you see what I want to illustrate. From data, we need to understand that the magnitude of F1 is said to be what? 300, because it's given already, newtons. And let us find the directions. So alpha is 45 degrees. Remember, from the x to the vector. So that's 45 degrees. Let us now find beta. Beta is 60 degrees. Remember, it's from the y to the vector. So we have 60 degrees. And then let's also find gamma. Gamma is 120 degrees. As you can see, it's from the z to the vector, 120 degrees. Now that we have that, let us express F1 in Cartesian. So F1 will be equal to the magnitude 300 cos alpha, which is 45, in the I, plus 300 cos 60 in the J, plus 300 cos 120 in the K. Yeah, like that. If we compute this, we have F1 to be equal to, we have 212.1320344. That's in the I. And if we do 300 cos 60, we'll get 150. That would be in the J. And if we do 300 cos 120, that would be minus 150 in the K. Now, if I round off my values to 2 decimal places, I'll have 212.13 in the I plus 150 in the J minus 150 in the K. Like that. So we have expressed our F1 in a Cartesian format. Like that. Now we need to also understand that we can as well express our resultant in Cartesian form. So our first resultant in Cartesian form, remember, it's only acting along the positive y-axis, which means it has 0 components in the I and 0 components in the axis in the K, but it has 800 as a magnitude in the J. So we have 0 in the I plus 800 in the J plus 0 in the K. So we have those values. So we have found the Cartesian form of the resultant. Let us also find the Cartesian form of F2, which is the one we're looking for. So the Cartesian form of F2, we don't know what it is. So since we don't know, the best thing we can do is to just give it some arbitrary values. So let's say we have what? F2. So F2 will be F2 in the I plus F2 in the J plus F2 in the what? In the K. That's what we're supposed to have. Now, you need to understand that the resultant is as a result of the sum of the components, or the sum of the values of the components of the F1 and F2, which means that for me to get my FR to be 0 in the I need to first sum up the I components of F1 and F2. Remember, we say that force resultant is equal to the components of the force resultant. We say the sum of the components in the I plus sum of the components in the J plus sum of the components in the what? In the K. Now let us sum up the components in the I and K. Now we're summing up for summing up the values in the I, J, and K for the components only, which is F1 and F2. So only this one and this one here. So if I say sum of the components in the I, for F1 in the I, we're having 212.13. So I'm saying 212.13 plus F2 in the I. So this is in the I. Then if I sum up the components in the J, I'll have 150 in the J from F1. So I'm having 150. Then plus in F2, I'm just having F2. So I'll just write F2, and that's in the what? In the J. Then if I sum up the components, since we're using this, if I sum up the components in the K, I'm having minus 150 there. So it's going to be minus 150 plus F2. That will be in the what? In the K. Now that I have my sums, I can now represent it in the what? Resultant format, so that we can easily understand what's going on. So let me erase some of the information that we have already understood. All right, going back to our magic pen, we need to understand that force resultant like I mentioned, is the sum of the forces in the I plus sum of the forces in the J plus sum of the forces in the K. You know, when you say sum, literally sounds homophonic with just sum of the forces that you have. Anyway, let's continue. So we need to understand that the resultant already has the components in Cartesian form that we gave as data here. So this implies that I will write those components. I will write 0 in the I plus 800 in the J plus 0 in the what? In the K. And is equal to the sum of the components in the I. In the I, the sum is here. So I would do sum in the I is 212.13 plus F2. That's in the I. Plus in the J, that's 150 plus F2 in the J. Then plus the components in the K, which is minus 150 plus F2 in the K. All right, now that we have that, let's create more space. Now that we have that, let us understand something. Magical pen. All right, so now that we have that, we need to get corresponding what? Values. The corresponding values, what I mean is by getting those in the what? In the I and J, K, just like that. So I'll start with the I component. For the I component, I have, so remember, it's the force resultant in the I is equal to the given force components in the I. So I'm having 0 being equal to 212.13 plus F2. Solving for F2 in the I, I'll be having, I can flip this and just have 212.13 plus F2 is equal to 0. You find the adjective inverse, so you can just cross the other side, or it jumps. I don't even know how, but it jumps. And when it jumps, the sign changes. So it's going to be minus 212.13, and that will be in the I. So that's the I component of F2. Now, let us find for the J component. Now, for the J component, we'll do the same thing. Remember, get corresponding what? Values. So we need to get the values that are corresponding. Remember, it's the resultant being equal to the given force. The resultant in the J has 800, and the given force has 150 plus F2. So this 150 will go the other side, and you have F2 being equal to 800 minus 150. So you have F2 being equal to, when you do 800 minus 150, you will get about 650, and that will be in the J. So we have in the I as well as the J. Now the last thing we need to find is in the K. So in the K component, so let's look for the K component. Remember, it's the resultant being equal to the given. So in the K, we have 0. So it's going to be 0 being equal to the values in the K, which is minus 150 plus F2. This minus 150 will go the other side and to be positive. Whatever that crosses the equal sign changes its sign. So this will be F2 being equal to positive 150 in the K. So now that we have the positions of the resultant in the I, J, and K, we can write it down. So we can just say, okay, force resultant is equal to its position in the I, which is minus 212.13 in the I. Then in the J, we have positive 650 in the J. Then in the K, we have positive 150 in the K, like that. So we now have the magnitude, the resultant expressed as a Cartesian. As you can see, we have it expressed as Cartesian. So let me erase this. Just want to write it somewhere so that we can see it neatly. So Since our first resultant is minus 212.13 in the I, then plus 650 in the J, plus 150 in the K. So that's what we're having there. Now that we have the resultant expressed as a Cartesian vector, our question asked us to, so not even the resultant, this is force 2. I don't even know why I'm saying resultants, force 2. Okay, sorry about that, force 2. I got caught up in the moment. So, now that we have our force 2, which is a component expressed as a Cartesian vector, the only thing that we need is to now find the coordinate directional angles of this particular component. Alright, so having this, we can now jump to finding the coordinate directions. So let us start off by first finding out the magnitude of this component F2, because it has its expression in Cartesian form to be that. So we know that the magnitude is equal to the root of minus 212.13 squared plus 650 squared plus 150 squared. So F2 magnitude, if you do that, you'll get 699.9993835. Therefore, you can say that the magnitude of this guy is 700 newtons. Why is it newtons? Because the other component, which is F1, is in newtons. So that's what we have. After that, we can now remember that the coordinate directional angles cos alpha is equal to the component in the I over the magnitude. So alpha is equal to cos inverse of the I component, which is minus 212.13 over the magnitude, which is 700. So alpha is equal to, if you punch that for alpha, you will get 108 degrees like that as your coordinate directional angle. Same thing with beta. If you do cos beta, you get the component in the J over the magnitude. So beta is equal to cos inverse of the component in the J, which is 650 divided by the magnitude, which is 700, and you have to get beta to be 21.8 degrees. I'm just showing them off fast. So if you do the same for gamma, remember cos gamma is equal to the component in the K over the magnitude like that. So you have gamma being equal to cos inverse the component in the K, which is 150 over 700 like that. So alpha is equal to 77.6 degrees. I'm skipping some steps because you guys can just punch them quickly. So I'm just punching them fast and just rounding them off like that. All right, that's that. So we have expressed one of the components that we never knew just by having the resultant value and one of the components given some coordinate directions of that particular component. We have managed to find this unknown component. All right, if you have queries, you can always reach me on WhatsApp on the line 077-149-5252. All right, thanks for watching. Remember, slow progress is better than no progress. Remember to strategize before becoming a statistic. Let's try and push for that A+.